In example 2, we want to be able to graph a shift of an exponential function. So shifts of the parent function f of x, which is equal to the base b with an exponent of x. Now for any constant c and d, the function f of x is going to equal b to the power of x plus c plus d, shifts the parent function of f of x, which is equal to b to the x. Now, it would vertically shift d units in the same direction of the sign of d. So it's either going to shift up or shift down depending upon that sign for d. Horizontally, it's going to shift c units, so in the opposite direction of the sign of c. So if it's plus c, you're going to be shifting it to the left. If it's minus c, then you're shifting it to the right. Now the y-intercept becomes 0, b to the c plus d. The horizontal asymptote becomes y, which is equal to d. And then the range becomes d to infinity. And the domain remains unchanged, which is going to go from negative infinity to positive infinity. Now for this example, we're given an exponential function with the form of f of x, which is equal to b to the x plus c plus d. And then we're going to graph the translation. So the first thing we want to do is we want to be able to draw the horizontal asymptote, which is y is equal to d. And then we're going to identify the shift as negative c, d. And then we're going to shift the graph of f of x, which is equal to b to the x, left c units if c is positive, and right c units if c is negative. And then we're going to shift the graph f of x equals b to the x up d units if d is positive, and down d units if d is negative. And then we're going to state the domain, which is going to be negative infinity to positive infinity. And then the range is going to be d infinity. And then the horizontal asymptote is going to be y is equal to d. So if we take a look at this example, it says graph f of x, which is equal to 2 to the x plus 1 minus 3. And then we're going to state the domain, the range, and the asymptote. So in order to graph this, we have an exponential equation of the form f of x, which is equal to b to the x plus c plus d, with b equal to, c is equal to 1, and d is equal to negative 3. So the first thing we want to do is to be able to draw the horizontal asymptote, y is equal to d. So we're going to draw y is equal to negative 3. So I'm going to go ahead and do this on one graph and then compare it to the one that's the solution. So down here at negative 3, we're going to draw our horizontal asymptote, and that represents y, which is equal to negative 3. Okay, and so then what we want to do is we want to figure out, okay, where is the y-intercept? So we can figure out the shift. I know it says step 2, but let's figure out the y-intercept, because the y-intercept is important to figure out where it needs to go. So the y-intercept is going to be 0, and then the x value is 0, and the y value is going to be b to the c power plus d. So we're going to have 0, comma 2 to the 1, minus 3, filling in the information that we have, which is negative 1. So let's go ahead and plot 0, negative 1 on the graph. So there is our y-intercept. Now we want to be able to identify the shift, and the shift is negative c, d. So the shift is going to be negative times the value of c, which is 1, so we have negative 1, and then we have negative 3. Okay, so I want you to take a look at this graph. This graph that we have right here is the family of functions graph. And so this is the graph that represents f of x, which is equal to 2 to the x power. Okay, and so what it does is right now it has a y-intercept at 0, 1. And so at that y-intercept, we can then shift the graph to the left negative 1 and then down negative 3, because that's exactly what that shift is telling us. So if we move over to the left negative 1, and then we're going to go down 1, 2, and then 3, well, there is our next ordered pair, which is our shift, which is going to be -1, and the other number is going to be -2. As you can see, that's how far we go. Now, we can take a look at other points on the graph to be able to figure out our shift, but we have to find points that are nice and easy for us to look at. So if we pick another point on this graph right here, well, that graph represents 1, 2. So if we want to use the shift, if we move to the left 1, down 2, down 3, then again, we're going to land on that y-intercept. So that's going to give us the value of 1, 0, and then -1, which is our y-intercept. Okay, and then let's do another shift. So we can find another point on this graph, which is up here, and that represents 2, 4. So let's do the shift again. So we're going to move to the right 1, and then down 1, 2, and then 3. So there is another point on that graph, and that point's going to represent 1, 1. And so now we have these 3 points. So now we're able to then draw this graph. So we just draw a smooth curve. So we can see this graph is going to go up, and then we know it's going to come down here, and then it's never going to cross the intercept. I'm sorry, the asymptote at y equals -3. So if you take a look, this version is a similar version to this. It's just the increments are a little bit smaller. You can see that 1 is in between the 2, but this graph resembles this graph. And so the domain is going to be -infinity to infinity. And then the range is going to be wherever the horizontal asymptote is, and that's where it starts. So it's going to start at -3 and go all the way to +infinity. And the horizontal asymptote is y equals -3.